All right, so it's been a busy last few evenings here, but I'm gonna run through some of the work I've done on improving the dock here. So this is the wireless charging dock. It has a cord that connects underneath. I took the cord out just to show this, but I'm trying to improve the passive design of the landing dock here, so that when a drone falls from roughly in the right area, this is what it's supposed to look like. But when it falls from, say, slightly over, it can make it. But if it's over too far, it's gonna miss, right? And I want the reliability of landings to be as close to 100% as possible. Right now it's like 20%, so it's a lot of work to go. But my thought, right, this is the dock that I bought that works for wireless charging. And the thought is, the initial thought was, okay, these rims, you could probably just extend them out a little farther, and it would improve the bit of a funnel that kind of funnels the drone. So if it's off by, say, like a little more, it might still make the center there. And so I got a 3D printer. It's the Bamboo Labs P1S, I believe. And I started. So the first thing I worked on, these are the first 6 or so, and there's maybe 2 or 3 misprints I had. But the first 6 designs here were just really optimizing this edge. So it's the outer edge of this dock, but it would be the inner edge of what I was trying to print. And I just wanted an edge that kind of securely enough latched onto here. And it took a few tries, but by probably the 9th iteration or so, I got it enough where, like, it was somewhat latched on. And now, so you can see where this is the new rim where it ends, and this is the old one. So if you drop it in say this zone, it does a pretty good job of getting to the center. So like that would have missed previously because it was beyond the rim. This landing leg here, you can maybe see the landing leg. If it gets hooked outside of the rim, that was one cause of them not hitting. And I'll go into some of the optimization fronts in a bit here, but there's a lot to do. But essentially, I want to start by optimizing this outer rim with some designs, and then at a certain point, also the inner rim. And I'll probably just remake a wireless charger myself at some point. And hopefully you can get it to charge faster, and also you could design it such that you could charge maybe multiple drones, with a dock, right? You might have a dock for 10 drones if you're doing some testing infrastructure set up there. So I've got this. So this was like, I don't know, my 9th or 10th iteration, but just kept iterating, trying to improve. One thing, so the way I set this up, I don't really know much, don't really do much like CAD or whatever modeling. But the way I thought about it is, I can maybe share the prompt here. But if you take a cross section of this, it's a certain shape, and I started with like a 5-dimension or a 5-point shape, and then a 6-point. And it ended up being a 7-point shape. But you can just define those points for the cross section here, and then I just told Claude, given the points, and I was measuring in millimeters, why don't you it would be rotate it 360 degrees around the y-axis here, and that defines the shape. And just given that and the points there, Claude was smart enough to kind of figure out the .stl file that I could use to 3D print it. And then when I want to iterate on the design, it's just a matter of adjusting the points a little bit rather than maybe trying to qualitatively describe a design. And it's hard to iterate that. So I think they call it parametric design. It's when you have sets of parameters that you're using to base your model. So anyways, this is like the 8th or 9th or 10th or whatever. And next thing I wanted is to try to make the rim a bit bigger. And so I got this one, and works pretty well. It's one of my better designs. The snapping isn't perfect, but it doesn't really have to be. I was very much operating like a good enough mode because we're iterating fast here. And so this does a decent job. The drone motors don't shut off at the very bottom. They shut off kind of here. So it typically falls a bit, and you can see it's scooting a lot more down into there. So and then I thought, okay, I'll just try. That worked well. I'll try to make it even bigger. And so this was as big as my my printer could handle. I think it's like 2 256 millimeters across the plate, I think, something like that. That's an even bigger one. And like if you drop it too far out, it's gonna run into the problem of like this. And so when I was talking about optimization fronts, essentially the outer rim you can optimize, the wireless dock surface itself you can. And then I was gonna really look at the bottom of the drone. Right now these landing legs, I mean, they work pretty well for a lot of cases where you're just landing on something. And it might protect the deck if you have a deck under. But in terms of the design for the wireless charging dock here, sometimes if you drop it too far, it's actually the legs. You can see the leg right there got caught. Maybe you can see it. The leg right there got caught, and that's what prevented the drone from really sliding on the bottom where I want it. And so I'm gonna try to find a file for those legs and then use that and redesign the legs there. And but I think I can get a pretty passive design that just almost always funnels the drone down into the center there. So this was one. And then what I want to try is a flatter funnel as well. And so you can see after this I had 2 misprints here, and I just wanted to include these in the process video here because, you know, it's not all perfect, but definitely run into hiccups. But I think for the 2 misprints, I think I tried making it too flat. And I think when the 3D printer goes around in circles and does the layers, if it's trying to overlay a layer too much, it has a higher chance of missing. And then I think stringing, I think, is the word they use in 3D printers. But it just starts causing all sorts of issues. And so I try to be mindful with that. But this was the kind of flatter one I finally got, and yeah, it's good enough here, good enough fit. So yeah, it was pretty good. And then that's where I started getting looking at this, and you know, just the way it's set up is the rim. You know, I maybe wish it were structured a little differently. So that's where I started optimizing the inner rim here. So I knew the coordinates I had set for making the outer rim. So in this inner rim bit, I could take those coordinates and then, you know, make the inner rim, and I took some measurements there. And but this is kind of my reproduction of this, and you know, it's obviously not a charger. It's just this is just plastic here. But I'm just iterating on it and getting the dimensions down here, and we'll sort that out. But yeah, I still have some work to do there, and improving that. You know, I think this was a step backwards in terms of like the design. Like this is a better design on the inner rim than this, but I learned some things, and now I think next is trying to figure out the prop guards, the landing legs and the prop guards, trying to smooth those out a bit so this really just funnels down to the center. But I have a better kind of dock. I guess I've been calling it inner rim, but it's really the wireless charging dock. I have a better one of those printing right now, and then I'm gonna work on designing some better prop guards here. So that's been my last few evenings. Pretty busy, but enjoying it a lot. So I can push pretty hard on this. But yeah, other than that, I ordered a third base station. The Lighthouse base station positioning systems. Those are the things up on the wall. And I looked in them a bit. I found an arrangement that I think I can rearrange that should have better tracking around the dock. So the better tracking on the dock is one thing. Improving the dock design as a whole, both the outside design and inside design, could be another thing. Smoothing out the landing legs could be a third thing in terms of improving the reliability of the drone landings. And then fourth, of course, is the software, the autonomy software could be another avenue. So I did some work with that, and I'm not doing a lot of coding myself, but having a Claude look at that and see what we can improve, and Codex as well, and I'll probably throw Gemini at it too. And but no, that's all going pretty well. So the one other thing I should note here is that with these big funnels, I did notice, and maybe I'll try to post a video, but essentially there's a ground effect for, you know, planes and flying vehicles when they get close to the ground. And I think it's conceptually, I think as it's pushing air down from like a helicopter or quadcopter or plane, you know, up in the sky, if you push air down, it can kind of just keep going down and there's less resistance. But when you're toward the ground, if you're pushing air down, it's going to get stopped at the ground, and then I would imagine like higher pressure maybe builds up, and anyways you get some more lift. But I noticed that a bit when with these bigger funnels, it kind of traps the air in more. Conceptual is my theory. I think how it's working, but I kind of noticed that with these bigger funnels, I was experiencing more ground effect with trying to land the drone there. So I have some ideas how to deal with that, but it's also not like a huge issue. I'll sort it out eventually, but there's one other thing to note. So yeah, I just wanted to film this this video on the whole process here, and the iterations. It's a very iterative process. You know, you try your best design, test it out, make some adjustments, make another design, and yeah, I'm really just going for a fast prototyping cycle here, fast iteration speed. I think it's gonna be key for me. So yeah, that's all I've got for now, but I'll try to get some more flights in tonight. So see how it goes.